Welcome back. It is time for notes. Yay, notes.
Yay, notes.
Now, today we're going to talk about erosion. Yesterday we did spend all of class talking about weathering. Real quick, Pon, tell me, what is weathering?
It's the breaking down of rock or rock-like material.
Excellent. Yes.
Thank you.
Weathering is all about breaking things down. Now, erosion is a little different. Once it's broken down, it has to go somewhere. So erosion is the movement of that broken down rock to somewhere new. So now that we have broken it down, we have to go somewhere new. This process is called erosion, and there are 5 ways to erode things. Way number first, it's going to be running water. We know that running water can break things down. That is one of our ways to weather things. It can be used to break down, but since it's moving, it can also be used to transport those broken down particles to a new location. Groundwater, another one. Groundwater is the water that's seeping through the ground, and it's also any water that's running underground. So it's not only the water that's seeping through all the soils, all the different layers, but it's also the running water underground. Wind. Moving air can move particles. We talked about this in our last unit, that wind can actually make things travel all the way across the globe. It's amazing. Get up into those global wind currents. Glaciers. Glaciers move. It's large chunks of ice that are moving. And when they move, they will crush, they will grind, and they will transport materials. Last, but definitely not least, ocean waves and currents can move materials from one spot to another. All right. I do love this picture. How that weathering happened, the erosion happened, and left us with this amazing rock feature. It's just kind of cool. Kind of looks like stacked rocks. But we know from our talk yesterday that this is actually everything else around it broken down and kind of sculpted into the side. Now, that's the whole purpose of erosion and weathering. It's to break things down and to make everything level. Currently we have hills, we have mountains, we have all these features that are raised up. But weathering and erosion, if you give them enough time, their entire purpose is to make everything back to one level, sea level ground.
Will that actually happen?
Will this actually happen? No. Because, yes, while they are always trying to break things down, we're also always building mountains. We learned about that in our last unit. Because of plate tectonics, are we not like the Himalayas? Are they not still getting bigger?
Yeah.
Yes. Are we also like the Mid-Atlantic Ridge? Is that making new land all the time?
Yeah.
Yeah, right now it's underwater, but eventually could it come through? The Ring of Fire, they're making new islands, adding to them. So, yes, this is breaking down, but there's also forces in motion that are raising up the surface. So will it eventually ever get to completely level? I guess it's theoretically possible, but no. So to continue, gravity will take effect. It will always pull things down. So part of erosion, we have all these things that are higher up. Gravity will work against that and will start pulling things down. As they come down, they're going to gain momentum. They're going to have more speed, more velocity. They're going to move faster, and they're going to, travel. It's going to be amazing. Man, oh man. See, it's a beautiful thing. This is your first introduction into physics. We'll get more into physics later. We actually get to do the math to figure out the gravity, the momentum, the speed, the velocity. It's going to be great. But That's more of a February topic, so we'll just leave it at this for now. And then when we get to February, oh, buddy, it will be a magnificent. Continuing. Gravity momentum. They are going to help carve out our surfaces. They're going to weather them. They are going to erode them. So the weathering and erosion is the carving out process. It's breaking down those rocks. Then they're going to be deposited somewhere. So every time we break down a rock, we have to deposit it somewhere. That is called the conservation of mass. We can't break it down without putting it somewhere new. We cannot create or destroy matter, because all the matter on Earth is still here. It can change shape, but it still has to go somewhere. So this is a balanced force. We are not making anything new. We are not getting rid of anything that's already there. Just like when we talked about earthquakes the other day, we had balanced forces. Remember, there's always forces pushing on each other. And if there's not an earthquake, they are balanced. Then when all of a sudden one of them becomes stronger, that plate will move. It will create an earthquake. That's an unbalanced force. All right, to continue. Wind, our next agent of erosion. Now here's another amazing background, another amazing slide. That bridge was actually carved out by the wind. Let's try it. We'll watch you do it. If you fall and get injured, I will not try it.
And I will.
But if you make it all the way across, we'll clap. All right. So this is in Utah. Yes.
I just wanted to point out that at 10:30 we need to leave for NJHS picture.
We've already talked about this.
We have.
All right. An arid landscape. Do y'all know what arid means?
No.
Uh-oh. Dry. Arid means dry. It can be cold and dry. It can be hot and dry. But arid means dry. That'd be an amazing vocabulary word to know. If you don't already know it, great time to write it down. Arid means dry. In a very dry landscape, you're not going to have running water. That's not going to be a way that you can break down all the rocks. So what are you going to have to use? You're going to have to use wind. Wind is going to pick up little bitty particles, and it's going to come around. It's going to hit other rocks at a very fast rate. These little bitty rocks hitting the big rocks. It's called sandblasting. So when the wind picks up small particles, carries them, they hit another particle. When it hits that second one, it's going to actually break it down. That is called sandblasting. The way that these things are deposited, they're usually deposited into one big area. We call them dunes. So the wind will take all those sandblast materials, all those small little bitty rocks that the wind can carry, and it'll carry them to a larger location and just drop them there. So they're carried along, they're deposited, and they make ripples. They make dunes. It's like waves in the sand. Right here is a satellite image of this. Now when we get to our CBAs, when we get to our star test, you're going to have satellite pictures of land features. Probably one or two questions where you get a satellite picture just like this one I'm showing you right here. It's going to ask you questions about that land feature. Right here is could ask you a question about erosion. Could ask you a question about deposition. Could ask you what type of feature this is. And this would be a sand dune. You can see the ripples in it. So we will have satellite pictures of these land features. And there's other land features that can be shown. I believe it was last year, it was either last year or the year before, they had a picture of a crater. And they asked a erosion and deposition question about the crater. Groundwater, the third type. So this cave right here is in San Antonio, Texas. Now, we talked yesterday about some different caves. We talked about Carlsbad. This one, another fine cave to go visit if you have the time. Lots of fun. All right. So rainwater goes to the ground. And the ground absorbs it. That rainwater still has to go somewhere. Gravity's going to pull it down. It's going to pull it down through the different layers of soil. It's called percolating through the ground. You've seen filters before, where water goes through a filter, goes through the different layers. And that's what it is doing in the ground. It's going through the different layers, going through the different layers. Eventually, it's going to get to a spot where it either hits rock and cannot go further, or it's going to dissolve out an area. So when it hits that rock, can't go further, it can create an underground lake. That's called an aquifer. It can create an underground river running groundwater. Or it can carve out caves. If the rock types are the right type, the acid from the soil and from the atmosphere as the rain's coming down, it can dissolve things like limestone. When it dissolves out a large area, that's a cave. So the carbonic acid from the atmosphere and the soil can get carved out as the water dissolves that rock. In this case, this rock was dissolved. Series of caverns. It's amazing to go look at. And after it's dissolved, it will redeposit. It will form the stalactites, the stalagmites. All these great cave features that people pay their hard-earned money to go look at. All right, glaciers. Glaciers, glaciers, glaciers. This is our next erosion feature. Now, a glacier is an enormous amount of ice. A lot of ice has a lot of mass. With all this mass, it's going to break things down. One thing about glaciers that a lot of people do not realize, they are moving. So this ice is moving. Gravity does have an effect on it. It's moving down. As it moves down the side of the surface, it will crush and break down that top layer. So that weight is going to push down, it's going to crush, it's going to move. It's going to grind. So all this debris that gets ground down is going to move down the side of the land with the glacier. This process created the Great Lakes. So it's actually carved out. As these glaciers went down the side, they carved out the land, and then they're going to leave everything that they had. So the erosion feature is the actual carving out, the grinding out as the glacier moves down the mountain. And then that ice is going to melt when it gets to the bottom. When it melts, everything that was left, all that soil, all that ground down rock is going to be left, and it's shown right here. So as the glacier melts, it's called retreating, it's going to leave all this sediment behind. And that's going to fill in the valleys. So there is your depositional feature, the moraine, what is left after the glacier retreats or melts. Running water, a river. And this is different from a glacier. A glacier is frozen water. It is moving, but it is not flowing water. Now, a river is flowing, and that's the key to this right here. Flowing water on the surface. We have rivers in every continent except for Antarctica. Frozen is not flowing. Yes, there probably are places that rivers would happen in Antarctica, but it's completely frozen. So they cannot be flowing when they are completely frozen. Now this is going to tie into our water cycle that we talked about before. We were tested on this in the last unit, and it's not going to go away. So they are the runoff section of that water cycle that we've already learned about. And speaking of this, we're going to have a few other things that we're tested on in the near future that we've already covered. It would not surprise me at all if we have a... It would not surprise me at all if we have a quiz on Friday, and on that quiz we have a moon phase question. Oh yes, the phases of the moon are not going away. Maybe we'll play the song on Thursday. That would be amazing. Or what if we had a water cycle question? We've already covered that, but we could have another one. Or some weather questions. I bet you want to see some weather symbols on this quiz. You never know. Anything that we've already covered is definitely a open topic for a future quiz or test. But I'm just letting you know, here's your forewarning. You might have something like we just mentioned. All right, so runoff will change the surface of the earth. It transports large amounts of sediment from one place to another. It also weathers, breaks down a lot of the surface of the land. So we have this nice frozen mountaintop. It's so pretty. And then the sun comes out and starts to melt some of that snow and ice. And it starts off as a trickle. A drip here, a drip there. But we have a lot of drips. And those drips add up. And they're going to gain some momentum. They're going to gain other drips. They're going to get some friends. And they're going to go down the side of the mountain. They're going to create a stream. And from there, that stream is going to combine with another stream. And those two streams are going to combine with another stream. And eventually you're going to get a river. A major river like the Mississippi River. It's going to cut through the rock. And it's going to find a way to get down to sea level. It's going to find a way to get to a lake and in there. Or it's going to find a way to get to an ocean and in there. But it's always going to find a way. But this is how lakes are created. This is how we refill our oceans. Because these rivers are going to transport that water. Gravity is going to be the key. Right here we have a picture of the Mississippi River. The Mississippi River. As the slope of the ground decreases, the water will follow it. And then you're going to get to some spots. Like this spot right here. Where you're not really sure why it makes a strange turn. Well, the reason it is, water's going to choose the easiest path. There's probably some feature right there, some high spot, where the elevation's a little bit higher, or it's a different type of rock right there, where the water can't just break through it as easily. So what does the river do? It's going to turn. It's going to find the easiest path. So it's going to create different twists, different curves as it goes through the land. Now this right here, we saw this in our video the other day. So this spot right here on the outside of this curve, remember anytime it goes around the outside of a curve, that water on the outside of it is going faster than the water on the inside of the curve. So the water on the outside of the curves is traveling faster. It's going to break it down. It's going to erode it. It's going to weather it faster than the water on the inside of the curves. We also have another curve right here on this side. So we have a curve on each side of this. And they're both breaking down all the land in that area. Eventually, this is going to make a straight path straight through there. Because each side of those curves are being broken down, yes?
Yes.
So as they break down, over time, this river is going to be joined. It's going to get rid of that little loop in the river. That little loop does have a special name. It's called a meander. So that bend, that curve in the river is called a meander. And eventually we will join that meander to make a straight line. All right, on this slide, you're going to see the different phases of making an oxbow lake. So we're going to start with just a normal meander. The water is coming, it's traveling, it's going around the curve. As it goes around the curve, oh my goodness gracious, it speeds up. As it speeds up, it's going to break down materials faster. So right here, on this curve, it speeds up, it's going to break down that material. You see it on this next picture. The material is broken down. So it's getting further over, further over. As it gets further over, eventually it's going to join because it got further over on this side too. It's joining, getting closer, and then it makes this straight path straight through there. When it does that, it's going to end up depositing things. So we're going to have deposits right here, we're going to have deposits right here. All these deposits are going to end up blocking that up, damming that up, and we're going to create an oxbow lake. So the final thing that we have at the bottom here is the oxbow lake. The river is going to run straight through, and that oxbow lake is not going to have that fresh water being added to it all the time anymore. So it's a meander that was cut off. So it's erosion that made it cut off, and deposition that dammed it up. All right, a couple more examples. These are rivers that flow into another river. So anything that's called a tributary is a smaller river that flows into a larger one. Now in Texas, we don't have any just huge rivers. We have a lot of smaller ones. You can go to places like the Mississippi River or the Delaware River, where there's places where you can barely see across the river because it's so far. There's just so much water there. It's deep, it's very wide. It's an amazing sight. The next thing we have is a feature called a delta. Now deltas happen when we deposit all this sediment that's been flowing in the water. So we have all this erosion happening, all this weathering erosion, and then it's traveling. All these little sediments are traveling. Well, eventually they have to be dropped off somewhere. So right here, all this sediment has come down the river, down the Mississippi River, and it has to go somewhere. So what you do is you create new land wherever that river ends. So right here is a picture of the Mississippi River Delta. This is at the tip of Louisiana. All this sediment from all up the Mississippi River has to be dropped off somewhere. And there are places throughout the river where it gets dropped off. Don't get me wrong. But most of it, or a lot of it, will travel down to the end of the river. It will create new land at the end. So all this right here is where the Mississippi River has dropped off sediment, enough sediment to raise the land above sea level. So a delta is new landmass formed at the end of a river, and the end of the river is called the mouth of the river. And looking at the time, we don't really have a whole lot of time to get into the oceans yet, so we're going to hold off on that until Thursday. What I want you to do for the remainder of class, you have homework this week. It is Unit 7, Lessons 3 and 5. I want you working on those two things until the end of class. So Unit 7, Lesson 3 and 5, we will finish these notes up on Thursday.